Instead of shop content, in this video I'm going to try and jump right into a bunch of considerations for planning, the location, size, construction, design, infrastructure, and a bunch of other things that come up for building a greenhouse. In specific, this is a Santa Barbara greenhouse, cedar and glass from a kit. And but I think a lot of the considerations here will apply to any other kit or self-made design. So while we're here outside, we'll talk about how we decided on some of our sizing and location. For size, we went with I guess I'll start first with why we went with a kit instead of designing our own. We've never designed or built a greenhouse. It seems like there's a lot of different ways to do it based on materials people have accessible to them or what preconceived notions they have about how they want to build it. We didn't really have an idea of like how structural or over or under engineered something like this needs to be versus a shed or something maybe more designed like a house. And we found that as we were researching possible greenhouse designs, some of them were just too either like kind of slapdash and utilitarian. Part of our incentive in building the greenhouse is that we wanted well-lit space for green, gardening and houseplant propagation and other things, because our house just doesn't get enough light and doesn't have enough south-facing windows. So for us, we wanted it to be an aesthetically pleasing space, and we didn't have the confidence that designing and building something ourselves for the first time as a greenhouse was going to achieve that. So then we started looking at kits. These cedar and glass greenhouse kits from a couple companies like Santa Barbara really caught our eye as very attractive structures. And so we thought about sizing first, and we said, okay, well, let's go with what maybe the widest they have, which this one is 15 inches wide across this dimension. And then we went with something just longer than that in the length dimension this way. We figured that that would give us room to move around inside for benches on each side plus some stuff in the middle, or if we wanted some low beds in the middle or at the ends. We wouldn't be tripping over each other or stuff on the ground if we went with the narrower ones that I think are 8, 10, or 12 feet, or something obviously less than 20 or less than 15. So we chose 15 by 20 because we were considering how we wanted the floor space to be used. And then we also laid it out. We staked it out on the ground out here. So for us, it is near where we're starting to plant some fruit trees and bushes, south of our chicken pen, kind of along this edge of our property. And then on the far side of the greenhouse is our garden. We figured in terms of location, this was a good open space that was kind of near related things, being this section of our property for fruit and gardening and chickens and stuff. In terms of what other stuff the greenhouse might provide, is there going to be power and water and storage space and supplies, things that are beneficial to have near some of those things. So we chose to site it here. We staked it on the ground. We confirmed that 15 by 20 kind of worked here. And we thought if we ever did want to expand it, before we knew exactly what kit or style we were going to use, we thought, okay, well, if we do want to expand it and maybe continue this design now that we see it and we can reproduce it, then we could extend it towards us on this side and not try and go further close to the fence over there. So those are some of the considerations that went into siting and sizing for us. The other would be, we had to figure out which way we want to orient it. Generally, it seems the wisdom is if you're trying to do season extension, which is the main thing we wanted, was this would be a 3-season thing, plus do some winter, plant maintenance. We oriented it so that right now the sun is over here. It's morning right now, so this side is facing east. The tilted roof on that side is south. So by running the spine of it east-west, that half of the greenhouse with the tilted roof has southern exposure to do that season extension, versus if you didn't want it to get maybe too hot during the summer and you were planning on doing other things with it besides season extension, maybe it would be rotated 90 degrees from here. And then as far as where the vents go, this design had 4 lower vents, 1, 2, and then on the other side, and then the 3 roof vents you can see. The wisdom we came across or that resonated with us is you want your roof vents to be on the lee side of where your prevailing kind of wind patterns come from. For us, the winds come basically towards the camera, or if not slightly more from the west to east most of the year. Especially with this row of privacy trees ending here, that's kind of where the wind comes from across this area. So with the wind coming from that side of the greenhouse, it helps draw hot air out of the top when the vents need to open and allow for ventilation. So other planning considerations, how to design or build versus kit. We talked about that a little bit. We build a lot of our own stuff. We fix a lot of things. We use salvage materials and a lot of stuff. And so this was a change for us to go with somebody else's design, somebody else's new materials, let alone in a kit from a vendor. As I mentioned, it was aesthetics and lack of our own confidence in ability to design something that we wouldn't immediately wish we did differently. And the knowledge that we could clone this design. If we found a good regional source of cedar and went to a glass supplier, we could even imitate this almost exactly with our wood shop. So I think some of that consideration is how you rate your own competency. If you've never DIY'd anything before, even the kits can be challenging. Santa Barbara, their designs are a little older. Their instructions are pre-CAD with a lot of sketches and pictures that are maybe not intuitive to people that don't have a sense for this stuff. And even for us, it was challenging sometimes to understand what the patterns were. And I'll talk more in this video. This might be a multi-part video depending how long this gets. But in this or another section, I'll talk about how we navigated some of those shortcomings in the instructions and maybe things that will be helpful for people building a similar kit. But even with the kit, that is to say, even with the kit, some intuition was needed, experience of having built or understood how loads shift, and are transferred between elements here. And if somebody was to get a kit and have somebody come build it for them, honestly, I don't even know how to recommend you finding like a handyman or a builder that does those kinds of things, except for consulting the vendor you bought the kit from. As far as costs, there's a whole spectrum, from the cheapest, plastic and whatever frame, structures to, big and, commercial warehouse, greenhouse things. The cedar and glass ones are certainly kind of in the middle in terms of cost and utility versus aesthetics and a compromise of all those things. We went with actual glass because we were just trying not to do something that with plastic where the panels are going to get damaged and have to be replaced and thrown out kind of regularly as they get harder. The roof panels here are plastic. They're double-walled polycarbonate. But I figured those were less likely to get damaged in our climate in the mid-Atlantic. We don't have hail or conditions that would break it. We were mostly worried about us hitting the side of it with things from the tractor, the lawnmower, the dog, or other things. So the glass seemed like a more durable and long-term option for us. You can't tell necessarily from here, but we have extra height inside. We thought about this ahead of time we wanted extra height inside in case we ever wanted to try to do some kind of fruit tree that would be work in our zone inside a greenhouse. We wanted extra height inside, but we didn't want to go up above the ground outside for a couple of reasons. One is if you want to do that and have it look nice, it's going to be a lot of masonry work, a lot of brick work, and we don't have a lot of experience with that or planning that or executing it. We weren't sure we wanted the aesthetics of this being like having a 2-foot knee wall plus the height that this already has. In terms of catching more wind also. We also thought that so what we did is we went below ground. We went down about 18 or 20 inches to get extra internal height. We also thought that might give us some extra temperature stability by having a big mass of crushed stone and just that section of the greenhouse that's below ground. The ground temperature will help moderate things. We don't have data to back that up really, but that was our theory on this. And then this let us do ground contact rated 4x4s as the foundation of it. Whereas if that went above ground, it would potentially look not so great. It wouldn't look so nice versus doing masonry. So we figured we'd go down. The trade-off, of course, is having to excavate that versus just building on grade. And we had the ability to borrow some equipment from a neighbor for that before we had our tractor. It also means that in the spring, our water table, our wet season, the water table in our clay soil is basically at the ground level. So we knew that we would need a sump pump in here. And we were okay with that. We knew ahead of time when we talked about it that even if the power was out or the sump pump failed and this flooded, nothing of any importance would be below the floodplain of the building. We'll talk more about that later when it comes to the electrical infrastructure that's in there. And then, so factoring in all of that, there's, what's the cost of your foundation materials? If you're just going to build it on grade with a little bit of gravel or maybe a concrete slab, you can calculate the cost of that reasonably. You just got to think ahead about it and factor it in. In our case, we knew we could dig it and build it for ourselves. We just needed to get the materials, the 4x4s. We did set the 4x4s on concrete pilings in form tubes because we didn't want to take the risk of this settling and cracking or popping glass panels out over time. We'll talk more about that. And then the cost of getting gravel delivered to fill in the base and allow for the drainage into the sump pit. Again, we're okay with that extra cost and complexity because we thought it would benefit us in temperature stability as well. Another piece of consideration for the planning stage is how much infrastructure do you want? Do you want lights? Do you want heat? Do you want water? Do you want sink? Do you want plumbing? Do you want a faucet? A spigot? Do you want a hose inside or just the hose you'd run in from outside? How much of those things do you want up front, and how much of that do you need to think ahead of time? Depending on your footing style, it might be easier to stub out electrical or power or other things before you put gravel down or pour a concrete slab or any of those steps that you take, before you break ground, so to speak. There could be order of operations to consider to save you time, especially if you're going to be using a plumber or an electrician for some of those things. You might want to consult with them on, hey, at what point should we have you here to do any pre-work before other steps? You're basically acting as your own general contractor on something like this, where you don't necessarily need a professional because the stakes are way lower than a house or some other kind of dwelling or residential or domestic structure. So you're acting as your own coordinator and general contractor, and you're also the customer. So it's in your best interest to try and spend time thinking about the order of operations, getting input from the experts that you might have involved later on what they need and when they need it. So now we'll go inside and talk about a little bit of what we did, maybe why we did it. And then later on, we'll talk about some of the things we probably would have done differently with what we know now. So now we'll go inside and talk about some of the infrastructure that we have that you might want to think about before, during, and after the point that you are planning and building a project like this. I'll do my best to show what I can with this narrow angle lens, but we'll see. So in our case, we have a bench running down each side. Those were included, the pieces for that were included in our kits. Due to us going down in depth, we did have to put some stone blocks under the legs to try and get the bench at a height we wanted and to have it be above the vents in the side walls. The benches seemed a little low for our desire otherwise, and they would conflict with the vents because we dug down deeper. A note on maybe Santa Barbara specific and maybe other kits is this center post was not included with our kit. Center post is needed to support the ridge beam when it's over probably 10 feet long because it's in multiple parts then. So we had to make that ourselves out of some locally sourced cedar from a sawmill. As you can see, we do have lights running down both sides. We originally had these, I don't know what they're called, rope lights or string lights or whatever, that where, they looked nice, but they weren't enough light if we were trying to do something out here after dusk. And then we also added fluorescent lights that give a nice amount of utility light in case it's getting, dark early at certain times of the year or heavily overcast around dusk. And so we have two types of light available to us. That sink was free from Craigslist. We decided to add it when we realized that the second bench was going in. We figured, why not? We can always throw a board over it if we need to use that space and temporarily cover it up. We have put a significant amount of electrical infrastructure out here for a few reasons. One is we started out with an extension cord just to power the lights and the vent fan at the top. Again, that came with our particular kit from Santa Barbara. And we have a thermostat controlling that automatically, which is not part of the kit. So another consideration is how you want to handle ventilation, whether it's all passive or power, depending on your climate. Even today, it's 35 degrees out in early February here, and it's already 75 degrees in here, and the vents are just starting to crack open to keep it from getting up over 90 or 100 degrees today if we didn't have any breeze and if it was in direct sun. So the electrical infrastructure is also for that heater. If it gets really cold here during the winter and we have something sensitive in here, we might try to keep it closer to freezing overnight to keep it from getting down below 10 or 20 degrees. We did the electrical work ourselves, so this may or may not be for everybody who has the knowledge or desire to seek that knowledge to do this. We ended up putting a 50 amp subpanel out here. Everything is designed and built for rain exposure, so we don't have to be careful with a hose in here or if it floods. You can see that the bottom of the panel is above the flood line of the foundation here. So if the greenhouse was to flood due to pump failure or power failure for a big weather storm or weather event, it doesn't matter. Yeah, any plants on the ground are going to get soggy, and anything we have below there is going to get wet. We'll be careful of that around wet weather coming or any extreme weather. But we kept all electrical joints and outlets and everything above the flood line of the greenhouse. And that way we don't have to worry about electrocution hazards or anything. And I think that's basically what code specifies anyway, is that in wet environments that are prone to flooding, you need to have everything above the flood line. Even these center outlets on the center post here are there. I mentioned in the last segment about planning ahead for power and water. We didn't do that. I wanted the flexibility of deciding later how we were going to do the layout inside and what would be the easiest way to trench power and water in here. In our case, so that's worth consideration is where's your power and water going to come from? How do you want to route it? Where's it going to come through or under a wall? In our case, the 50 amp subpanel is powered by a feed from our shop over here. It's a 2-inch PVC that runs up past the chicken pen, past the shipping container, and into the side of the building over there. And the water is going to come when we finish it straight in from the hydrant and the well, the water line that runs under the center of our yard. We'll end up trenching that in under the sink now that we kind of have a little more idea how we'll do that. And it's not so hard to pull this gravel back and run conduit or water lines under here if we wanted to get water back to the center post for this hose recoil that we use here. I mentioned we do have a sump pump in here because we are below grade. So that was all secondhand stuff I got on Craigslist. Got a pump and a float switch, although I might replace it with a solid state thing to make it more reliable. The ejection line temporarily goes out through a window here, but we do intend to put a couple of palletized water, liquid containers outside the wall here and keep some of that groundwater, as well as potentially put some kind of gutter on the greenhouse so we can collect water and use it throughout the year for watering things in the greenhouse and the garden. So that's an upcoming project in that category of infrastructure. Similarly, we thought about using some of these hydronic water heated mats to either heat the building or distribute heat on the benches or do like a solar battery in some water drums that sit under the bench and maybe have the mats on the bench during the day, where they're not covered in sun, they'd be able to heat up the water, store it in the tank, and then at night have it run, once the temperature's dropping, maybe circulate the water back through the mats to heat the space with a Raspberry Pi or something like that. So there's all kinds of infrastructure options like that. We're also thinking about how to do the lower vents right now. So for passive cooling and ventilation, these lower vents, there's no automation to open those. The top ones are on some kind of non-electric automation like a wax actuator or something. They're actually pretty clever. So these open and close automatically from that arm there at a certain temperature. But to get airflow through here that uses the roof vents appropriately, these bottom vents need to be open. So I guess we could get actuators for those, or I've thought about maybe a way to run a shaft with that coils the ropes up that pulls them open from a motor that has a thermostat, either again through a Raspberry Pi that does stuff in the greenhouse. And that way we can have them kind of open and close in conjunction with the roof vents to maintain the desired temperature or humidity in here. So there's all kinds of options for automation, as probably anybody nowadays considers. But that's pretty much what we've thought about for infrastructure and the kinds of things that might be worth considering for a project like this. The heater was part of the kit. We paid a couple $100 extra for an upgrade to the kit for a bunch of these little things to, because the pricing wasn't bad for what it is versus piecing it together ourselves over time. At least unless we saw everything used or salvaged from somewhere. So we put in an outlet for that. That's a 6 kilowatt heater with a 30 amp outlet there for it. So yeah, that's some of our infrastructure and the things that you might consider. It comes down to a lot of your climate, what your goals are for the greenhouse, whether you want to heat it. We have these misters here for adding humidity and doing a little bit of swamp cooling at different times of the year. And we even added, so that is controlled by this orbit scheduler here. But we didn't want it running when it's actually too cold out here on like an overcast day, even during the summer. So I have to remount it still. But we have this RV heat thermostat, or I guess it's a cooling thermostat, set to 80 degrees in line with the DC power that runs the solenoid here. I can't remember if it's AC or DC. Whatever it is, it's like 24 volts. So we have that RV thermostat so that the scheduler will still run, but if it's below 80 degrees in here, the solenoid won't get power. And that way the mister won't run when it's dark, rainy, cold, whatever it might be. In the future, if we ever do have a Raspberry Pi in here that is controlling a whole bunch of this stuff, it could easily just serve as the relay for that, and we could do away with the dedicated schedule here or repurpose that for other things. So I mentioned all the power and water stuff that has kind of evolved in here. We improvised it all at the beginning. We knew we were going to do it properly and nicely and to code and with the right materials and design eventually. But we spent the first year or year and a half kind of improvising everything. We had a garden hose come in through the window for water. That's what gave water to the misters and the hose reel in the middle. Power came from an extension cord coming from the shop or the house, I can't remember, for the sump pump and the fan. And we kind of just waited to see how we used the space because we didn't know for sure up front how we wanted to invest our time and money and the materials to do this a certain way. So that's another valid approach. Instead of over-designing things at the beginning, just keep them in mind. Think about these things at the beginning, and that way you can prototype as you go, but not close any options off prematurely. If we had done a poured concrete slab in here, it would be a lot harder to run power and water potentially to like the center of the space. The center pole is what brings power and water up for the mister and the lights as well. So if we couldn't get power or water to that and we had poured a concrete slab here, we'd be kind of stuck. We would have to, we could run power and water up the side to the middle, to get things to the roof as well, but it artificially closing options off to us by not thinking about things ahead of time. I'm going to talk about some of the construction-specific stuff of this Santa Barbara greenhouse that I think other people with kits from Santa Barbara or kits like this from other people would benefit from knowing as it supplements the instructions. I don't recall that the instructions gave a really good overview of like the philosophy of how this is designed. It's designed in modules that you pre-assemble, and then you put them all together later on site, so to speak. We made the mistake of having the kit delivered and moving all the boxes of it over here, when in reality we ended up bringing every single piece of that back to the shop, even the glass, to assemble the panels in the shop. So looking at this end of the greenhouse, you probably can see these panels on the ends, because this is 15 feet wide. These panels are 3 feet wide. 1, 2, 3 for the center, 4, 5, giving you 15 feet. Once we understood that, we were then, it took way too long for us to wrap our head around exactly what the final construction looks like, because we needed to understand that to do the foundation exactly right. We hadn't built the panels by the time we were doing the foundation. We wanted to start the foundation earlier in the spring and work on the panels, in the evenings and throughout when we had free time. If I can sketch it out and overlay an image, I will, of like how you would calculate the outside footprint or the centerline footprint or whatever's useful for the foundation. Because we didn't understand, for example, from the instructions before the panels were built, how the corner is assembled. You know, which panel overlaps which panel at the corners here. That impacts the outside dimensions of the whole thing. And as you can see, the end panel, which is over here, overlaps the side panel coming from this direction. And that ends up being pretty important to calculating the exact outside footprint so you can design your foundation correctly. When you're working with, 2x3, nominally 2.5 inch, or nominal 3 inches wide, 2.5 inch wide pieces this way, and a 4x4 foundation that is 3.5 inches wide, that's not a whole lot of room for error. If you're off by an inch or two, you're going to be in a really painful situation when you're doing final assembly and realize that your wall is either going to sit, one of your walls is going to sit inside or outside of the foundation. I don't think Santa Barbara published a really clear site plan type of guidance on that, and it would have been helpful. But as I walk around this, hopefully I can talk about details like that, which helps somebody understand how to plan your foundation and your footprint with these things in mind. All right, quick minute on the foundation sizing. The panels are more or less exactly 36 inches wide on the short side and 48 inches on the long side. This gives us a panel width of 20 feet, 0 inches on the long side, and 15 feet, 0 inches on the short side. Except the short side wall does sit outside, over the end of the long walls. And the edges of them are, the 2x lumber is on its side for the end panels. So that adds 1.5 inches at each end of the structure. That means that the long side of the structure, the outside dimension, not including the trim, the structural dimension is 20 feet, 3 inches. And across the short side, it's 15 feet, 0 inches. Of course, the foundation, being 4x4s, is 3.5 inches, give or take, in width, meaning it's 1 inch wider than the 2x3s, which are 2.5 for the structure. So this gives us, on each wall, there's an extra 1 inch of width to figure out what we want to do with on the foundation. If we want to go on center, it's going to be a 1/2 inch lip, give or take, inside the structure and a 1/2 inch lip outside, in terms of putting the center of the wall on the center of the foundation. So that gives our foundation, if we want it to be on center with the wall, our outside dimension of the foundation is going to be plus 1 inch in each direction because we were gaining a 1/2 inch on the outside per wall. So our final outside dimension of the foundation would be 20 feet 4 inches by 15 feet 1 inch. If we wanted all of the excess to be on the outside, well, then it would be plus 2 inches instead of plus 1. But in our case, we said, okay, we're going to shoot to be in the middle. So we have this 1 inch extra divided by 2, and we give ourselves a little wiggle room on exactly how things end up, in case things don't end up perfectly straight or whatever other errors we have to accommodate. So for the 15-foot wide, those panels are each 3 feet wide. I don't know if I'm sorry, I don't remember if it's exactly 3 feet, but you can calculate it based on the sill plate of each. Those are all numbered and laid out in the kit for probably any manufacturer. Obviously from that you can tell the exact width of these panels, and then knowing how it overlaps the corners, then you can calculate the footprint and work backwards, figure, okay, exactly, I show the top corner, but obviously the bottom corner doesn't make contact with the foundation. Then you can work backwards to figure out exactly what your footprint of your foundation should be. And we've never built something that required a foundation or a footprint, kind of planned in the ground like this. Maybe this is more intuitive for other people, but for us, it was a lot of extra kind of thought to say, okay, how does this thing get put together? How does that impact the 4x4s on the foundation? And then how do we place our concrete footings, the form tubes below that? Especially when you're talking about the precision of like the bolts that you set in the concrete to come up through the 4x4. And then we did half lap joints for all the 4x4s going around the whole thing. Or we did the half lap for the first course so that they could overlap on the concrete footings. On the long side, and maybe this might just be because it's 20 feet, so it's 5 panels wide, each of which is 4 feet, giving you the 20-foot width. And again, these all are assembled ahead of time. I'm actually going to go to the other side where the sunlight's over my shoulder. Probably should have shown that joint here. So you can see looking up here that the end is actually as an end cap on the whole structure. And that's true down below, in this case, our mulch and dirt we have stored here as well. The panel design is pretty straightforward in the Santa Barbara kit. All the grooves and rabbets and whatever are there for the glass to be recessed. The way it's designed is that the glass sits in a recess along the edge of the structural element on the inside. Then there's some foam, like weather insulation tape, that pads the glass and helps it kind of sit securely against the wood. And then the glass is retained, by this double-sided tape, but also the trim that gets nailed on over the outside. So you can see this like 3/4 by 1 1/4 or whatever this is trim that frames every piece of glass effectively, retaining it. And this is where, if we had the hot dip galvanized nails, these would probably not be staining the wood quite like they are. There you can see the dark spots were our nails. These have been out for about 1.5 years now, and it's just, the cedar gets gray pretty quickly after you have your first weather, and then in our case these electroplated zinc covered nails, zinc coated nails, started staining the wood, and we're fine with that. That is what it is. It beats hammering every single nail, and maybe if we looked a little harder we would have found hot dip nails that would hold up a little better. All of the vents on the Santa Barbara one are straightforward. They use these plated hinges to hinge out. Again, this is some of the instructions didn't necessarily cover very well of exactly how you put this on. It came down to intuition and either creating or having intuition of how this goes together, even with some knowledge of the basic physical concepts involved. It took a little longer than I wanted to be like, okay, I know exactly how this is going to go, and understanding like, okay, yes, all the water that runs down this side, if rain's hitting this glass, it's going to end up running down behind the vent and into the greenhouse, and that just is what it is. That's fine, but in theory, it might be nice to have the instructions call this out of exactly how this sits, or make recommendations of, how far you want the hinges above or below, the bottom sill of the window there. Or it took us a while to figure out that there's no trim that covers the bottom of the glass here. That wasn't, I think, explained in the instructions, and we had to kind of lay all the pieces out to figure out, like, yes, there are indeed no bottom trim on the window sections. It's small stuff, but maybe having this out there will help somebody who's thinking about building one of these. The roof panels were kind of fun to assemble. They're like 9 feet long by these would be 4 feet wide also, at least in the 20-footer. A lot of screws here. We actually maybe either put too many screws or just came up short on them. Bought some other ones for the last panel or two. They're kind of fun to make because they're so light. There's no glass in them. The glass panels and the glass is kind of heavy to work with by yourself at least. But making these big panels, and we did it on a bench in the shop, so we weren't working on the floor. It was nice to go through and make 10 of almost the same thing. The 3 with the vents are a little different, but same general assembly. About maybe mistakes we made or things we would do differently. Maybe some things that we're glad we did. We did break one piece of glass while we were building things. The Santa Barbara instructions talk about they ship you bags of nails to hand nail everything, which is good. That makes it accessible for people. But we did not feel comfortable, especially with the glass on these. We did not feel comfortable hammering every nail, especially because the nails retain the trim, which retain the glass. We ended up using a nail gun for almost everything, including especially the benches. They shipped you nails to do all these bench slats here, and I can't imagine hammering every single one of these, especially because these 2x3s for the frame of it are so flexible. The hammer the whole thing just bounces and makes a racket. So we were glad to have a nail gun. Unfortunately, we couldn't find hot dip galvanized nails. We had to use bright finish zinc, electroplated nails, galvanized nails, which are not going to hold up as well as the hot dip nails that they shipped. But that was a trade-off that we were okay making. We did break one piece of glass with the nail gun. It just caught the very edge of the glass, and being that this is all tempered, the whole thing immediately shattered. It was one of the shorter pieces over the window, and we just had to source a replacement from a local glass supplier, which wasn't too expensive of a mistake. I can't remember what it was, but it was fine in the grand scheme of things. We had all of the roof panels are optionally, you can caulk them as you put them together. We did do that just to keep it from being too drippy and wet in here when it's raining, in case we're out here doing things. Again, it's optional. A greenhouse obviously can be wet, and it's meant to be wet inside. In hindsight, I probably would have bought a powered, battery-operated caulk gun, especially some of the tubes of caulk that we bought were quite firm. And we ended up buying that later on for a different project. I wish, in hindsight, that we had it for this. I did not think ahead of time about the height of the benches. When we decided to dig down, I did not think ahead of time of the height of the benches, which I mentioned earlier, with wanting them a little higher off the ground. I mean, digging down with the length that was shipped, they would have ended up at the height, in the inside height that was intended by the designer. We didn't really want the bench running through the middle of the window, the middle of the vent though. And for where we're doing a lot of repotting or sprouting or starting seeds or transplanting things here, we wanted the bench a little higher to working height for us anyway, like countertop height in the kitchen. So it did end up working out for us that these, I don't remember what the name of these kind of stones are, but one of those on end kind of got us to just the right height to go above the window and let us kind of grade things out, and they don't move around much over time. We've not had to make any adjustments in the last year to these. Well, this bench we just put in, but the other one we haven't had to make any adjustments. So I didn't think about that ahead of time. It worked out pretty well. I also, because we dug down, I did not think about how to handle the door. Oh, I've got to back up to get this in frame. The door height, I can't remember quite the specifics of this. I think what happened is I notched out the top 4x4 for the door before thinking about what that would end up meaning for the door frame and the door height itself. And we ended up having to cut, I guess what it was is the door height it's designed to sit in your 4x4 foundation, and we didn't cut this, and I didn't want to cut the door, so we cut a notch in the top 4x4 instead, which just means we couldn't grade the dirt up as high around that side of the building as we wanted. I should have given that more thought beforehand. And related to that, we'll go outside and talk about some of the site planning, the mistake that we made. So one oversight we made when we were selecting the location and the foundation style for this is we didn't quite set it up high enough compared to the surrounding ground. We did 5 courses of 4x4s, and the top one is basically just level. I don't know if I can really show it. The top one is really just level with the ground. So ideally, we probably would have had one more course above the ground. If I hold this pretty much level, you can see that our ground here is actually tilting. It's graded down from the right. And so this side of the greenhouse is the uphill side. It's very, very slight. The greenhouse ideally would have sat higher so that we could create more of a swale or a valley here for water to come in. And we still can. We can dig down, but we're going to have to spend more time planning how that drainage works. It hasn't really been a problem. Water does sit here a little bit after rain, but it does drain around and through the greenhouse. We'll probably make improvements to that over time. But that's the single biggest thing that I didn't give enough appreciation for when we designed this is we dug out the foundation of the greenhouse, but I did not really get like the 8-foot level out and think about where the top of the foundation would end up compared to the surrounding ground. We had dug out behind we started building the 4x4 foundation, and maybe I'll stitch some pictures into the video. We started digging that out, and we didn't have a good reference for where the final ground height was going to be because we had dug out the foundation around where the 4x4s were going to be as well. It's pretty minor. We got lucky that it wasn't worse. If this was set below ground by accident, which we were careful not to do that. So we were paying attention to it, but it could have been a lot worse if we weren't, and we ended up accidentally putting it below ground, such that water wanted to pool against it, and we would have had to come further back to regrade and let water flow around it. Now that we have some trees and fruit bushes planted here, the last thing we'd want to do is have to regrade this area further back to go around this. So very small compared to the mistake we could have made there. The other thing we're going to do, it's not something we'd do differently, but something we hope to do, because we have this extra vertical height inside above the bench, we might create a second tier of benches above it, above the first one. Maybe not full depth, but so like a shelf, a couple feet above the first bench. Maybe just on this side, the north side of the greenhouse. That would let us have more space for smaller plants that are in here through the winter or the summer or season extension, tools and materials that otherwise clutter up the benches. You can kind of see here now. Maybe we would, water wouldn't do that on the south side where we want more light to come in. We wouldn't want to block too much light close to the windows if we want it to filter and reflect around the rest of the greenhouse. So we're still kind of pondering that part over. I mentioned earlier about digging the foundation out. We were lucky enough to be able to borrow a very adorably small excavator from a friend of ours. It's the guy who actually bought all this gravel from, was willing to loan that to us to dig the foundation of this out in his off season. And that was pretty critical to the success of this. We did look at renting an excavator before we knew that he might loan us one. And it would have added to the project. It was something we had to consider. We did end up buying our own tractor about a year later. In hindsight, we could have we would have benefited from having that for the pace of this project ourselves, but we used the tractor to do some of the final grading around this, and then also where the electrical conduit comes out here, runs up past the chicken pen and over, as I mentioned earlier. We were able to trench that with the tractor, whereas we would not have been able to borrow equipment to do that in a meaningful amount of time. By having our own machine, we were able to take our time on how we want to do that and do it right, do it down to the right depth for freeze, ground frost, and safety reasons. There's some other small quality of life things that weren't included in the kit, but we realized we needed pretty quickly once we started using this. This door spring, I don't even know what to call this, prevents it from slamming open, particularly if we're leaving the door open for in warm weather to allow extra ventilation. If the wind catches that door, it would come back and it would either over open or it would hit some of the dirt here, and you could tell it was going to break something if that kept happening. So there's little things like that were worth solving and investing into to prevent breaking the door or glass or hinges or door frame. So I think that's it outside. I'm going to talk inside about a little bit the final construction order of operations and a little more about the center post. So once all the panels were built, we put the whole structure up in a weekend, and that included making this center post. For us, there was a little bit of an order of operations thing that, again, maybe we made it too complicated or overthought it. We didn't know what the height of the inner post would be, and once we realized that we had to come up with our own post, it was like, okay, well, how do we calculate exactly what I want the center height to be inside? We didn't know what the ridge height would be. So from the bottom surface of the ridge beam to the ground, we couldn't really figure out from the instructions what that was going to be. And it wasn't until we had the walls up that we could kind of piece it together. I suppose we could have measured from the gravel to the top of the foundation, and then this door section I'm standing in, measure from there to the notch that the ridge beam sits in. But what we ended up doing was put up the walls on one day when all the panels were done ahead of time. We moved them out here, stood them up with 3 people, made it easier. 2 could have done it. 1 would be sketchy. Then the next morning we put the ridge beam across. We did one half of it. We leveled it. We temporarily braced it up with some 2x4s and took a measurement from a piece of stone. There's just a thick piece of slate on the ground, in the gravel, not the dirt there. We took a measurement of what the post height would be. And then this cedar actually came from the same guy that we got the gravel from, and I borrowed that little excavator from. It's 4 laminations of rough sawn cedar with the bark still on the outside. We took these, we planed just the 2 outer faces, and then cross-drilled and bolted them together with hot-dip galvanized 3/8 carriage bolts, and then the hardware is on the back. And to what degree this is an aesthetically pleasing structure, we tried to keep the nicer side of everything facing the door. That's why like the plumbing and the electrical is not on the front face of the post. Once we saw this post come together, it was originally a deep purple before the UV hit it. We realized it was worth kind of trying to keep that nice as the first thing you see coming in, because this is a hobby greenhouse, not a commercial structure, and we have some pride in what we built. But because it didn't come with a post, it came with minimal hardware to figure out what to do at the top of the post. I don't know if I can get a good shot of it, but there's this bracket that we welded up. I'll include some other pictures of that maybe. That joins the top beam, or the top post we made, joins that with the ridge beam at the top. And that came out really well. It's actually not painted. We did a hot oil finish on it, and I'm amazed at how little it's rusted over the last year and a half, and including 2 wet winters now. That's held up really well. There's minimal hardware to join the 2 pieces of the ridge beam together, because it's really, they just mainly need vertical support. Everything else is braced. In terms of lateral movement, it's braced by the walls and the rafter ties. There's one at each end of the building. It mainly just needs the weight taken care of in the center of the structure for the 2 pieces, the 2 10-foot pieces of the ridge beam. So we're really happy with how that came out, and that's actually become quite the little feature in the middle of this. Pretty much wraps it up. Anything I forgot, I'll stitch in with some pictures and voiceover while I'm editing this. Overall, we're pretty happy with our purchase. It was a much bigger project than we anticipated, even with a kit. We may have overcomplicated things with digging down instead of building up, but I'm happy with the result and the effort that we put in. There's not too much that we would have done differently. The biggest one is just siting it 1 course of 4x4 higher above the surrounding ground. And my hope is that this video helps anybody who's thinking about designing, building, or constructing whatever aspect, the various aspects of projects like this. I would love to hear from anybody that this is helpful to, or additional content you would have liked to hear about it. When we're doing some more alterations to this, maybe I'll capture some of that if I think it's helpful enough. I'm not here to recreate content that other people are making for their respective channels. My goal is to try and get useful guidance or brainstorming content out, but not have it all just be about sharing the product, because everybody has their own unique project and goals. So thanks for watching. I hope this is helpful to at least a few people. So now I'm going to tell a brief version of the kind of the story of our construction, things maybe I didn't mention earlier in this video that come up along the way. I will try and keep it brief, because I don't particularly enjoy videos of people talking through pictures at too much length. This is how things were delivered. Again, this was a Santa Barbara kit, cedar and glass, with a deluxe upgrade that included the benches, the heater, and I think that might have been combined with the upgrade to the glass as well. The delivery from the local freight affiliate wasn't great. All the flat boxes ended up falling off the back of the truck, and the glass crate, the delivery driver didn't have a way to get it anywhere except right on the edge of our driveway, and it sat here for quite some time before we could figure out how to drag it with the truck when the ground was frozen, to try and get it somewhere else. We broke ground. That was delivered in mid-fall. We broke ground the next spring, kind of early, when things were still wet, but we wanted to get going. We ended up digging out the footprint, digging a hole to throw a sump pump in, and just constantly fighting rain, snow, and mud. I guess ideally we would have done this once we were through the wet season of our late winter, spring time, but we were eager to get it going because the materials had already sat outside over winter through the fall. Those boxes were all stacked behind our privacy trees, and we were worried about the materials getting damaged as things sat longer. We laid out the footprint with some string and stakes to help visualize where we were working and sight the lines and stuff. We figured some of this out as we went. The challenge for us was once we were trying to sight some of the other parts later, these strings were all up above the footprint. We couldn't quite figure out how to do this, but below ground, so that we could sight the the concrete form tubes and the 4x4s. Maybe the right way to do it would have been to dig the footprint out extra wide in all dimensions, but that would have added more time when at this point we were ready to start putting the form tubes in. You can see the ground started to dry out, but we still had occasional rain and mud and had to keep dealing with that. So I found a couple of broken augers, two-stroke 40cc or so gas-powered augers to drill into the ground for the form tubes. Fixed them, got one good working one out of 3 dead ones, and we augured. We wanted to get about 24 to 30 inches below the base of the hole here. Really that's overkill, but 24 to 30 inches below grade would have been enough. But we ended up augering basically as far as we could before we hit the really hard pack, hard pan clay that we have. Then we knew we were down to a really solid point to put this on. It's not a heavy structure, but as I mentioned earlier in the video, we really did not want the glass to ever risk popping out or the whole structure twisting or deforming. This is where we had a real hard time figuring out how do we site these tubes effectively, and how we didn't know from past experience how precise we needed to be on this. How much error in the alignment of these is okay. We tried to get them vertical because we didn't want to have them risk tipping over if the ground was really soft and there was enough weight on these. If they weren't vertical enough, they might start to lean eventually in the mud. So we did get them vertical. We braced them with, packed some dirt around there with the digger bar. But we didn't know how important it was to get them in line with each other. What's the error we can tolerate? How much error can we take out when we set the J-bolts in the top of the concrete later? So we spent time being maybe a little more precise than we needed to here. We were within 1 or 2 inches ultimately, even though we were trying to be better than that. It ended up being 1 or 2 inches, probably maybe 3 in some cases, and we were able to make up for all that later. It was worth us being as precise as we thought we were being, because by the time we got these all plumb and aligned as best we could, we still weren't as good as we expected to be. We leveled the tops of them so we wouldn't have to cut the tubes to length. We did cut the tubes to length, and then we also leveled them so that we knew the concrete pour would be at the right height without having to try and cut the pour short. So we had all the tubes set. I think this was the end of this day. And again, this is over weeks. This was over a number of weeks of work. So I'm breezing through this, but I don't want to give the impression that this all happened in a weekend or anything. This was weeks of intermittent work, waiting for weather, waiting for things to dry out. So we had the tubes all ready, and then I think it was either the next day or the next weekend we were ready to mix and pour the concrete. So that's what we did. We had everything here. That concrete mixer was also bought locally and broken. It had an electrical issue that I fixed, and kind of just salvaged everything as we went to keep the project down, especially for tools we didn't think we were going to use again. Borrowed that motorized dump cart after repairing it for somebody, and ended up mixing up the batches of concrete, pouring them, and then setting the J-bolts in. I can't remember what these lengths were, but the half-inch J-bolts that we used pieces of cut up 2x4 to float them in the top, and then wrapped them with bags and plastic wrap to let them cure. And of course it rained the next night anyway, so we had to pump everything out again. This was just the theme of this project, and it was what it was. So for the first course of 4x4s, all of our concrete pilings or footings were on 5-foot centers, roughly, give or take a couple inches, as I mentioned. So we had 10-foot 4x4s and used them in pieces to cut them into half. We cut half lap joints and everything, so that each end of each 4x4 could be supported over each footing. It was a little tedious, but with my wife and I, we got a good assembly line going, and as usual, we got good at it as we were doing the last one. And then counterbored a hole for the nut and washer to go on each. And I hit them each with a drop of green penetrating Loctite for good measure. That's probably unnecessary. These are going to be located and serve their purpose even without a nut and washer in theory. But it got things nice and clamped down, and we knew it wasn't going to move while we were doing the rest of the foundation work. So did burn out one sump pump. Again, I got a bunch of used and broken ones on Craigslist from somebody. This one was the smallest one that was easiest to throw in the pit, and at some point it must have filled with too much mud and it just burned out. Exploded the capacitor, melted some of the wiring, but I ended up putting new wiring in a new capacitor and I got it working. But in the meantime, I was running out of pumps. That was the one one that I had fixed already. Ended up breaking out this antique to pump out one morning. This is a 110-year-old pump with a 70-year-old motor from another project. But got that pumped out and started layering on the rest of the foundation. And we ended up doing 5 courses of 4x4. As I mentioned, ideally we would have done 6 or 7 to have this end up slightly above ground, slightly further above ground. But it is what it is. Then we went inside. We had a bunch of the panels made. So these are the side panel, one side panel, and then behind that is an end panel. We had made some of these while we were doing the foundation work, and then we turned our attention to getting the rest of these built. So doing the framing of the side panels, and then we went through them one by one and put the glass in and the trim, and then we would move them to another area to store them until we could get everything done. Same with the end panels, which were taller and heavier. Even though they're 3 feet wide instead of 4, they were quite heavy due to their height. So getting all the glass and everything. Even the vents, same thing. This is kind of the state of the shop as we were going through and assembling everything, all the materials needed, the weather stripping, foams and the hardware. And then the one mishap when nailing the trim on with the nail gun, just caught the edge of, nicked one of these panels and did pop the glass, and took a few weeks to get a replacement for that since it was tempered. Then we had all the panels ready, stored in another area to keep the shop workable room available as we worked on the final panels, storing them anywhere we could. And then the roof panels, in our woodshop we have a couple of big benches that are on rolling casters. We were able to move them into place, put 2 together, giving us a 6-foot by 9-foot workbench, which was nice for getting these panels assembled on a nice elevated working surface. And the instructions on this were pretty good. Where to caulk and seal things together, and then the screws to help keep everything kind of clamped. This was at the ridge. They really, you want to seal potential water ingress near the top, and then by the time it gets to the bottom, you don't need to seal as carefully because it's going to be running along the edge and drip off anyway. What I didn't expect is that the overlap at the end of this, I was like, oh, this is nice. It forms a drip edge so the water doesn't run right down the side of the greenhouse. That's not true, as you might have noticed earlier. This edge overlaps the side walls, so it ends up exactly coplanar with the vertical surface of the sidewall, and the water does in fact just run down the edge. Ideally, I would have liked if the design had an extra inch so this could run off and form a drip edge and not run right down the side of the greenhouse. So at some point I might think about how to put gutters, just either some kind of wood or maybe PVC if it doesn't look too terrible, gutter on the edge of the wall near the top that can catch the water and then let us also store it. So we had all our roof panels lined up and ready to go, and at this point we're pretty much ready for final assembly. We're getting into midsummer at this point. The weeds started to grow all around the foundation. We had the last of the gravel delivered straight into the footprint because the ground was dry enough for the truck to deliver straight to it. So we pulled all the weeds out, got ready for assembly, prepared the rest of the gravel before the walls were up. And then, as I mentioned earlier, it was 2 days basically to get the structure up with all the work done ahead of time on the foundation and the panels. The first day we stood up the outer walls. This is about halfway done that day. This is how it finished at the end of the day. This picture was probably taken the next morning. So we were ready to address the final end section in the middle and then calculate the height of the ridge beam so we could make that center post. Once we did what I had described earlier in the video about getting the first half of the ridge beam up, measuring what the height was going to be after it was leveled, we did pull some of that cedar we had and plane the outer faces, and it was this beautiful purple color that went away within 24 hours of being in UV outside, but came out really quite nice. Then we did a little bit of water sealing or linseed oil on it, welded up this top bracket so that the bridge beam could sit on the center post, made some brackets to attach the bottom section to the slate that it was going to sit on in the gravel. This is the top bracket finished and oiled. This is heated up and brushed with oil. I can't remember if it was vegetable oil or linseed oil or something else. And once that was installed, we were now ready to put the roof panels on. And that went nice and quick. So right before starting the roof panels, we did put the second end panel in opposite the door. A couple close-up pictures of different things. And the roof panels, I mean, with 3 people, we got a good system of having someone on the ladder inside, having somebody else inside, having it hoisted up over the outside wall, handed up, bolted in place, run a bead of caulk along the joint for the next one that's going to come in, tightening the bolts, and it went really quite well. So after the 2 days, the final assembly looked something like this. Over the next week or two, we chipped away at grading around it and figuring out how we wanted to navigate the drainage, since we realized it didn't sit quite as high as we wanted. Then we worked inside on the benches. The dog wasn't thrilled because he had just gotten the snip, but went through, put in the one bench a couple weeks later. Actually, I guess this was the next spring. We had our own tractor and worked on the electrical work finally, so we wouldn't be running extension cords over anymore. The extension cord was just enough to do the pump, run a fan, the exhaust fan, lights occasionally, but we wanted to get the permanent subpanel in now that we knew kind of what our requirements were going to be, and in case we ever needed heat as well. So we ran trench down quite deep, deeper than it had to be, 24 to 30 inches pretty much the whole way from the shop, and 50 amp subpanel here. And I didn't mention earlier, we ended up feeding this with a GFCI breaker from the shop, so that if there was any fault to ground in here due to water or damage or something, we would avoid electrocution hazards. You would immediately trip upstream with the normal 10 to 50 milliamps of fault current. The downside being that if the sump pump starts to fail or the exhaust fan gets a little wet and starts to short the ground or something, that could cause nuisance trips, which, I mean, those are legit issues to diagnose, but because the GFCI would trip upstream in the shop, it would be a little more annoying to isolate what potential intermittent fault there is on something. But that was worth the trade-off for the extra safety for us. Extra shot as we're getting ready to backfill. This is about 30 inches down, and we backfilled about a foot, tamped everything, and then ran red caution tape, about a foot above the conduit, so that if anybody is digging through here, they hopefully will hit and recognize the tape before digging further and disrupting this feed. So here is the end of the backfill, where we can see the caution tape and kind of just doing the last 5 or 6 or 10 feet here, kind of all at once, whereas the rest of the trench has been filled in, backfilled, tamped, and everything. And that pretty much brings us to today, where we started the video off. So that's all. Kind of already wrapped it up in the previous segment, but hoping this helps anybody who's trying to decide how to go with a project like this for a greenhouse or other outbuilding, DIY, kit, design options. Who knows? Maybe this is helpful brainstorming. Maybe this is not. Happy to help anybody else in the comments with any other questions that might come up. Thanks for watching.